Hello, I'm Nam. Welcome to my lab experiment. So the purpose of this experiment is that we're going to be talking about the motion of a spring mass which is dropped from rest and displays characteristics of oscillation. The reason that this displays this is because we're entering the z-dimension in this experiment because the object is moving back and forth vertically and also horizontally. In this experiment, we want to compute the energy changes using the predicted model to show changes in kinetic, gravitational potential, and spring potential energy, which will all equal the change in total energy. The results from this lab are that the change in total energy is supposed to be equal to 0, which mine is very close to, and that the predicted and observed model are nearly identical. Okay, so now we're going to be talking about the physics principles in the lab. So first we have to go over Newton's second law because we are working with forces here and the net force, which is the combination of Fg plus Fs. Fg is gravitational force, which is equal to negative mg in the y direction, and then S spring is going to be the negative k constant times the length the spring minus the relaxed length of the spring times L hat, which is the direction. And then we're going to have some velocity and position update, which happened later in the lab during the coding. And because the force is not constant, V average is going to equal Vf plus Vi over 2. Next, we have the energy principle, which is the kinetic energy, which is half m, and then V final squared. And then the potential gravitational, which is mg delta h, which is the change in height. And then the gravitational spring formula, which is half of k, again times s, which is the length of the spring minus the relaxed length squared. Then the energy of the system is going to be the three of these added together. Then the spring constant I gathered from the equation 4 pi squared m over t squared. And then last we're going to have the static equilibrium position, which is the F net is equal to Fg plus Fs, which is negative g in the negative y direction, and then plus ks in the positive y direction. So for this lab, I did have to make a few assumptions that all the data that Dr. Greco gave us was correct. Because he was the one doing the experiment, I had to trust that the mass, the spring stiffness, and the relaxed length given by him were correct and accurate. For the initial conditions, our initial velocity is going to be 0 because he dropped it from rest. Our initial time is going to be 0, and the initial position is what Tracker gave me for the very first point. Then for our systems and surroundings, the reason that I had these separated is that for the forces, a system cannot cause itself to move. And so because of that, like the system is just the object, where the surroundings are the spring, earth, and hand, which is causing it to move. And then for the energy, the system is everything because all of that is being accounted for in the total energy. Then here's the video of Dr. Greco dropping the object. As you can see, it oscillates and moves in a very seemingly random direction compared to our last few labs. Okay, so now let's look at the data in the graphs. So first, looking at the bottom left graph, this is going to be our total energy graph. The change in gravitational potential energy, which is the red line, and the change in the spring gravitational energy, which is the green line, are opposite in sign and oscillate, causing them to equal 0 when added together. However, the blue line, which is the kinetic energy, while also oscillating, does not offset the magnitude of the other energies. And because of this, delta E is not perfectly 0. As you can see, it kind of wiggles a little bit, the orange line. And then the position versus time graphs show that the model is accurate at predicting the y position, but it is not as accurate as predicting the x position relative to the y position. So in the next couple of lines, I will be showing my coding, which is nearly identical to the scientific principles in the beginning. For that reason, I will not be going into very much detail, but here I'm just showing that the gravitational force is equal to negative mg, that the spring force is equal to the spring constant times s times L hat, and F net is the addition to both of these, and I'm also updating the position and velocity of the ball. So in the first few lines of this code, I'm using the information Dr. Greco gave us in order to find the characteristics of the spring, and then the second part, I'm calculating the energy changes using the equations and the physics principles. So on the left here, I have a free body diagram, which just shows the forces. So we have that force of the spring opposes the force of gravity, and the force of gravity is going towards Earth. This does not account for the energies, which is why there's no oscillation shown here. Now for the errors in this experiment, I did have a lot of difficulty finding delta T in the coding, and for that, I had to guess and check a lot, which could have proved to have less than accurate results. I also could not account for drag force or air resistance, which would have been solved using the equation here. And on Tracker, I had to hand select the center of mass, which as you know is not very accurate. And I also could not account for a lot of other energies that could have been involved in this experiment. Now kind of going back to the orange line that we saw earlier, the energy principle was not satisfied fully because if it was, that orange line would have been constant at 0, but it was pretty close. It's just that the kinetic energy did not have a small enough magnitude to offset the rest of them. And then also just kind of going into the periods of the oscillations. Between the x positions, it was 1.638, and between the y positions, it was 1.521. And as you saw in the graphs, the x positions weren't exactly relative to the actual one, and the difference in seconds was 0.117. The difference can be caused by the errors such as air resistance / drag forces, the unknown energies, and temperature effects, etc. that we don't know. Thank you so much for watching. Have a great day.